So we are asked, how in the world can we make this molecule from some starting materials? So we need to think retrosynthetically, and that's what the problem does. It lists 4 options for you if you're getting this from the textbook. But if you're doing it here, I want you to think a little outside the box. How can we make this molecule, not given a multiple choice format, but we're asked to just think with our brains? Okay, so I want you to notice what our product looks like it was made from. I'm going to redraw our starting material here. We have a phenyl group, a ketone, and then we seem to also have a group here. I'm going to notice something. I have a ketone, and then I have an ester group. This to me is a signal that this was a claisen condensation product. Why do I say this? Well, we have the ester here, right? If I have, for example, this here, and I add it to this one, right? I have to use sodium hydroxide, but I make an enolate. And then I form carbonyl where I attack this. And then these electrons come down to reform pi bond and kick off our methoxy group, for example. I'm going to get this here, and I'm sorry I'm blocking, but I kind of have to see here. It's a little tricky. Notice here, well, actually, we reform pi bond. Sorry, that would be one away, wouldn't it? Right. No. Okay, sorry about that. If you notice here, we did this here, but we got this product. It's a similar looking thing here. This group is analogous to this group here. This group here is analogous to this group. So we're asked, what reagents could we use to do a claisen condensation and make that? Fair question. Let's think about it logically. How I approached this problem is I said, okay, I'm going to split the molecule up. I knew that on this carbonyl there was a ethoxy group, right? Because if we do a mixed one, we're going to get a mix of products, right? A mixed claisen gives you a mix of products. But if we use the same one here, we're going to get the same product. So let's try and keep it symmetrical here so it's a little bit easier. So I knew that there was an ethoxy group, right? Because we want to match that this was an ethoxy. I'm going to break the bond that we attached, which is this one here. Okay, we cleave the bond. And what are we left with? Well, I'm going to clean up. Notice that we have a phenyl, a carbon, and then the ester. We have a phenyl, a carbon, and then the ester. Do you notice something? That's actually kind of cool. We have a symmetrical, we can make symmetry if we just cut a bond and add the ethoxy group. So what we did to make this group here is we used 2 of these groups here, right? And then we took sodium hydroxide and some of the what's it called? The corresponding ethyl alcohol, or geez, it should be like that. Methyl. Put a methyl, not an ethyl. What's wrong with me, right? So we're gonna protonate this. I'll actually draw out the mechanism for you if you really need the help, but if you're looking for the answer, it's that one. So click off if you're this far. But if you want a proof that it really is this, I'll go ahead and draw it out. I don't mind, right? Because I hate when you look at practice problems, they give you a solution, but you don't really understand it, so you have to kind of go back and you're like, oh, what? Try to figure out for an hour. No, I won't do that. I'm not evil. Let's attack with our sodium hydroxide. We're going to take another equivalent. And this is going to come and attack the ketone. And you get phenyl. Actually, let's draw it like this, shall we? this should be another carbon like this, and then so we have, or no, what am I doing? What? No. I'm imagining carbons right now. I love when this happens. Okay, so we have ethoxy, we have our carbon here. This should be a phenyl as well. We attached here, so we have. Okay, that took a long time. And then carbonyl just kicks out our ethoxy group. I won't bother drawing another arrow, but the ethoxy group will get kicked out. We'll reform carbonyl, and it will go be more like that. Okay. So notice here we have exactly what product we started with. So we have the phenyl, carbon, ketone, carbon, phenyl group off to the side, ketone, ester. So that's how you go about these sort of problems, right? You in the problem, if you got it from the textbook and you're searching it up for a solution, you got a list. But if not and you have to think about it like that, right? All right, I hope you guys enjoyed. If you did, please drop a like, subscribe, comment if you have any questions. Hope you have a wonderful day. Bye-bye.